AutoTRAX has the unique ability to create many different parametric parts, where each parametric part will automatically generate the footprint or land pattern, the 3D model, and the schematic symbol for the part. To give you a quick feel as to how a parametric part looks, here we have a classic dual inline parametric part consisting of 8 pins. Here you see the footprint pattern in a basic form that shows you the pads for the footprint, complete with pin numbers. In addition, you can see the part's reference prefix, which in this case is the letter U, which stands for an inseparable assembly. You can also see the automatically created silkscreen. The parametric part also automatically creates a part placement point, which is used when creating part placement files. A courtyard is also automatically created. The courtyard is used for auto layout, and by the design checker to ensure that parts do not overlap. You can also see a representation of the automatically created 3D model in the footprint. The parametric model, as previously mentioned, will automatically generate a 3D model for the part. Here the 3D model is placed on the small PCB demo board. You can see that the 3D model also comes with automatically generated solder around the base of the pins. You can optionally hide this small PCB demo board, allowing you to view the part from many different angles. The parametric part also generates a schematic symbol. Here you see the symbol for the part with the pin numbers displayed. However, the names for each of the symbol terminals cannot be automatically generated, as the parametric footprint has no information about the terminals. This information must be entered by yourself, from information in the manufacturer's datasheet. You can see in other AutoTRAX tutorial videos how you can get the terminal names by simply clicking on each of the terminals in the manufacturer's PDF datasheet. I will now show you how to quickly create each of the parametric part types currently available in AutoTRAX. Here, you see a blank new project. I will create a custom part that will form the basis for the parametric parts that I will create for you. In the Home Ribbon menu, clicking on the Custom Part button in the New Ribbon button group will create a new, non-parametric part with no footprint pads. To show the 3 different views of the part, I will tile the views horizontally. The initial, non-parametric part consists of a footprint with no pads. There is a symbol schematic, consisting of a terminal magnet, which is used to attach symbol terminals. As there are no pads in the footprint, there are no symbol terminals. There is also a 3D view showing the sample PCB that the footprint is placed upon. I will now go through all the different parametric parts that are available. I will now go through each of the parametric parts that are available in the Footprint Builder panel. The first one is the dip parametric part. Clicking on the button creates the parametric part with the default parameters. For each of the parametric parts that I show you in this video, they will be created with their own default parameters. However, you can change the parameters individually to customize the parametric part to your liking. I will set the part type text to my part. You can use whatever text you want. You can even have multi-line text. On the left you can see the automatically created schematic symbol, complete with the 8 symbol terminals associated with each of the pads in the footprint. In the middle view you can see the footprint. It is displaying the 2D representation of the 3D part that is automatically created. Now, it is displaying the footprint's pads, silkscreen, and part reference. On the right, you see the 3D model that has been automatically created. You have to do absolutely nothing in order to create this 3D model. AutoTRAX has created it for you. There is no need to import 3D models, with their inherent inflexibility and excessive memory and file space usage. I will now quickly go through the other parts that are available. The next part is the SOIC part. Next, we have a quad package. Note that in the schematic symbol, the symbol terminals are placed on all four sides of the terminal magnet. Next is a BGA. If I hide the part base in the 3D view, you see the solder balls on the underside of the 3D package. Here is a male header. Followed by a female header. There are two types of sockets. The first one is the box socket. And the second one is the XT socket. Now we have a collection of SOT transistors. SOT 143. SOT 353. SOT 23. SOT 89. SOT 223. And now, an SOT 252, or DPAK. Next in line is a TO 220, with optional heatsink. Then a generic metal can package. To the right is the ubiquitous TO3, with optional heatsink. Then a TO92. On the next row is a chip package. Followed by a block package. And to the right is a crystal package. Next, the all-pervasive axial package. Finally in this row is the SOD323 package. Now we come to the MELF package, which stands for metal electrode leadless face, but sometimes means most end up lying on the floor. Next is the radial package. Followed by the disc package, often used for capacitors. And last on this row is the all-pervasive LED. On the penultimate row we have the inductor PCB pattern. The aerial PCB pattern. The edge connector. And last, but not least, the castellated PCB. I strongly encourage you to create a new custom part, and have some fun investigating all the parametric types available. It will be time well spent.